So in general, we're going to say y is m times x plus b. And we say that the m and the b, m and b, are real numbers. So in other words, they're just some value. And the x and y are variables. So to kind of clarify the difference between what makes something real and what is a variable, what I mean here is it's just some fixed value. Okay, so m and b are fixed, meaning they're chosen ahead of time. Meanwhile, x and y can be any pair of numbers that makes this equation true. They're variables, but they can't just be any chosen numbers. They have to be pairs of numbers that are solutions. Let's not forget that. That's what we just learned recently. Alright, so to demonstrate this in a very slick way, what I want you to do is pull up on a separate screen Desmos.com, and what I want you to do is literally type y equals mx plus b into the window here. So I'll try to show you what I am looking at. Okay, so here's Desmos. And in this box that has the blinking cursor, just type y equals mx plus b. And then see how it says add slider m, b, and all. Go ahead and hit all. Okay, so here's how this works. You get to choose any m and any b value. And just play with this. See what happens if you make m bigger and smaller. Okay, so there's m as 0. And then just reason what you're witnessing. Okay, what do you think this controls? Okay, so let's choose an m value of 1. Okay, so here's m equals 1. We see that the line is just what we call increasing. So from left to right, it just keeps going up. So we call that an increasing line. Now we're going to do what is called fixing m as 1. Okay, so we're not going to move m anymore. We're going to fix it as 1, and now we're going to let the variable b vary and see what that does. Now you might say it's moving the line diagonally left and right. But in reality, what you're seeing is this graph is actually shifting upward. So to demonstrate what I mean by when the b value increases, the graph is actually sliding upward and not diagonally, as this kind of shows. Okay, so let's just fix the b value at 0. Okay, so we have this graph. Now I'm going to click here and insert a different equation for a different line. So I'm going to choose an m value. Now notice we have a graph in front of us with m value 1. So I'm going to choose the m value 2, and then I'll put an x next to it. That creates a line. And then I'm also going to add 0. Now what I want to do is give you the same line. So here we go. I'm going to choose the same m and b value. So essentially I'm creating the same line. So notice if I turn it off, you see the original graph, and then if I turn this on, it's overlaid on the original graph. Now the b value currently is 0. So notice what happens when I change that 0 to a 1. So now we took the red graph and we slid it upward by 1 unit. So it's still almost the same graph, except now it's just up 1 unit higher than it was previously at the origin here. Now it's up here. So you could think of this original point 0, 0 has now been shifted up to 0, 1. And that's what the b value does. Okay, it shifts this graph up by 1. So if I put 6, now the graph went up by 6 units. Okay, so what we're saying here is this point 0, 0 is now at 0, 6. Okay, so that's what the b value controls. It controls really where on the y-axis this graph is going to cross. Now the m, you noticed back over here when we were, let me turn this off, making the m change, we could see that what it affects is steepness. Okay, later on we'll explore more about the steepness of a graph, which we call slope. I've said earlier that y equals mx plus b is a generalization of linear graphs. So does that mean every linear equation is written in this kind of form? The answer is no. For instance, you can have something like y equals 2x plus 3. So this is written in this form y equals mx plus b. But we can use algebra to rewrite equations. Okay, so what I mean by that is we could start, for instance, subtracting both sides of this equation, let's say by 2x. And the reason why I chose 2x is because I'm going to essentially move this 2x over to the left-hand side when I do this. And now the equation becomes y minus 2x equals 3. It's the same equation, except now it's written in a different way. If I were to graph this, it would still be the same graph as the original equation. Now that I have y minus 2x equals 3, I showed you that it's still a linear equation, but it's no longer in y equals mx plus b format. Okay, so this is going to happen when you're dealing with linear equations. Sometimes they're going to be written in a different fashion. And what we need to get used to is rewriting equations into this format, y equals mx plus b. Y equals mx plus b is very helpful when you're finding points and also graphing. Really our goal. We wish all linear equations to look like this. And so our next example we're going to see is how to graph an equation that is not currently in y equals mx plus b format. Let's go ahead and turn the page here. Okay. So let's say we had to graph 3y minus 6x equals 12. Now, so far the only method we have for graphing an equation is we make a table of values and we find some points and we plot those points and then connect them with a line. So here's our table. Right. I have x's and y's that I want to fill in here. So remember, you typically get to choose the x and find the y, but notice this is not written in y equals mx plus b format. Currently it doesn't look like this. And that's fine, but typically you're gonna want to rewrite your linear equations where y is being solved. In other words, y is isolated to one side of the equal sign. Now, why is that? Why do we want the y by itself? So let me just demonstrate to you the disadvantage of having our equation currently as 3y minus 6x equals 12. We're going to generate an ordered pair to put onto our table. So I'm going to choose an x. I'm just going to say choose x to be 0. So what I want to do then is put this 0 inside this x here. Okay, so then we have 3y minus 6 times 0 equals 12. Now 6 times 0, that's going to be 0. So then we just have 3y equals 12. And then I'm going to divide both sides by 3. That way this eliminates. And now I have y by itself. And I say then that y is 4. Okay. So when I chose x to be 0, I ended up having to solve for y, and I got 4. So, okay, so there's our first ordered pair that we generated. Now, did you catch the disadvantage here? When I chose an x, there was still some work to do to get the y value, right? I had to do a little bit of algebra. The little bit of algebra is I had to divide both sides by 3 in order to get the y value. Compare that then with how things would be if I didn't have to do this step all the time of having to do algebra to get to the y. It would be nice if I just plug in an x and instantly get my y from calculation with no algebra necessary after I plug in x. So what I want to do is take this equation 3y minus 6x equals 12, and I'm going to solve for y. Okay, so that means I want to get y by itself on one side of the equation. So I'm going to move this 6x using addition. I'm going to add 6x to both sides of this equation. So negative 6x plus 6x eliminate. Okay, and I'm left with 3y here equals 12 plus 6x or 6x plus 12. Right, so I could also write it as 6x plus 12. So now I still don't have y isolated, so what I need to do then is divide both sides of this equation by 3 to eliminate the 3 next to y. So now we have y equals this fraction. Right, y is 12 plus 6x over 3. But I don't want it to stay like this big fraction, so what I'm going to do is break it up into two separate fractions of a common denominator. And then now I have 12 over 3 plus 6x over 3. And then I'm going to reduce this. 12 divide 3 make 4 plus 6x over 3 reduces to 2x. Now we have y by itself. This means we have solved for y. And realize I could also write the equation like this. Could also say or y equals 2x plus 4. So now that I have a different version of this original equation that's being solved for y now, look how nice it is to get my y values. So instead of using the original equation that we had up here, I'm instead going to just use y equals 2x plus 4. It's the same equation. Now if I chose x to be 0 and insert 0, look how easy it is now to get my y value. Now I just calculate 2 times 0 plus 4, y is 4, and I'm done. Okay. So let's generate another coordinate. Let's choose any x value really that we can graph. So let's say x is 2. Okay, so then I'm going to insert 2 into my equation. 2 times 2 is 4, plus 4 makes 8. So y is 8. Okay, so when x is 2, y is 8. I'll go ahead and put that on my little table here. 2, 8. So now let's make a little graph. So let's go ahead and get rid of all this. Alright, so there's my xy axis. We'll go ahead and plot our 2 points, 0, 4, and 2, 8. So 0, 4, here's 1 point. And 2, 8. So notice my axis only goes up to 7. So we should probably just generate a different point. Let's say we chose 1 instead for x, and let's go ahead and plug it into the equation to get our y value. Okay, so we get y equals 6 because 2 times 1 is 2, plus 4 makes 6. So 1, 6 is a different point we can plot, and we'll put it right there. Okay, and then we'll take our straight edge and we'll connect these 2 points. So what I'm gonna do is just grab the line shape and connect. In summary, my advice to you is when you're generating points and your equation is not of the form y equals mx plus b, go ahead and do a little bit of algebra at the beginning and manipulate this equation so that it becomes solved for y, and that'll just make finding points a lot easier. Also, if you wanted to graph this equation into your TI calculator, you would have to know how to rewrite this into y equals, because the TI calculator, the way it's designed, when you try to graph something on it, it only accepts equations that begin with y equals. So I wouldn't be able to type 3y minus 6x equals 12 onto this calculator. So that's another reason why we would want our equation to look like y equals mx plus b.